Welcome back. So we are here to draw conclusion of the particle size distribution which we have made in very early lectures. So the question is, what is the use of finding percentage finer than a particular size d of soil of different class? Let's try to understand this by making some simple observations. First of all, note it down that the particle, the how it is represented means you have taken some result, you have drawn out some result, and finally you have to represent that result in any pattern. So here the result of particle size distribution is represented in form of a curve. Okay, that curve is called as particle size distribution curve. So the particle size distribution results is represented in form of a curve. In form of a curve, and this curve is called as particle size distribution curve. So what is the speciality of this curve is there are two coordinate axes. Okay, everyone knows there will be two coordinate axes. Let me pick the pen. So this is x, sorry, let it be y in general notations, and this be x. So along y-axis, percentage finer that we have computed is mentioned, percentage fineness, and along x-axis the dia of soil, that is soil size, is written or mentioned in logarithmic scale, log scale, log scale, and y scale is normal scale. Okay, why log scale is included in along x-axis only along one coordinate direction? Because to incorporate the large variations in the size of solid, okay, to incorporate all sizes, the log scale is being used. So along this is what I am writing, it is normal scale, and x coordinate direction is log scale. So what is representing, what is the aim of representing now? Now the second aim, we now need to draw the second aim, that what is the aim of representing the data or the result in form of particle size distribution curve, what it signifies or what it shows, what you can understand by looking at a particle size distribution curve. So the statement goes like, the particle size distribution curve okay, we are ready here. So the particle size distribution curve gives idea about two things. First, type of soil. That is, by looking at particle size distribution curve, you can interpret that whether the soil is of gravelly soil, whether it is a sand or silt or clay. This is the understanding about type of soil. We can find out the type of soil by looking at particle size distribution curve. Why? Because the particle size distribution curve consists of two parameters. Along x coordinate axis, the size is being represented under log scale. So, by looking at the size or by looking at the start position of curve, that is the starting position of curve, that is from which particular size it is being started, the curve is starting on x-axis, we can tell that it is a gravel soil, it is a sand, it is a silt or clay. So just by looking at the position of the curve along x-axis. So the starting position of the curve represent the type of soil, okay, on the basis of size, size D. Now the second objective is what we can draw out just by looking at the particle size distribution curve is gradation of soil. Under gradation, a soil may be of following types. A soil may be of a soil. It is not necessary that it is gravel, sand, silt, it may be anything. So I'm talking in general. So a soil may be of well graded type, means sand may be also well graded and silt may be also well graded individually within itself, well graded. And how this all comes, we will look when we will study the IS soil classification system. Okay, for now understand the terms: well graded soil, second poorly graded soil, graded soil, third uniformly graded soil, and the very fourth one is gap graded soil. Gap graded. So which property of the particle size distribution curve predict all this? The shape of the distribution curve gives idea about the gradation. Okay, so this shape represent its gradation and the position of curve represent the type of soil. So you should remember this. These are being asked several times in objective, that what does a position of curve signifies in particle size distribution curve. Simple, it signifies the type of soil, which type of soil it is, and for gradation it is compared by the shape Let me take an example. Let us draw a particle size distribution curve. Just look at this curve. So these are these sizes: log 80, log 20, log 10, means these are range between 10 to 20. This is the meaning of log. Within this space, all the diameters is included within 10 to 20 mm. So log 4.75, let this be log 75 micron, let this be log 50 micron, let this be log 2 micron. Okay, so and here percentage fineness, percentage finer than a particular size. So let there are curves such as, let there be a curve which goes like this. Let there is another curve which is something straight. Let there is another curve which is this fashion, in this fashion. Let there is another curve which looks like just it is being started and it goes like this. Okay, so just name it. This be curve A, this be curve B. Which one? This brown one, curve B. This be curve C, this be curve D. Now look at that, look at the curve. The starting position of the curve represent the type of soil. That is, for curve A, the starting position is at 2 micron and it is proceeding towards the higher sizes. Means on basis of sieve analysis, after conducting the sieve analysis and understanding the idea about soil classification, we can decide that whether the soil is fine grained soil or coarse grained soil. Okay, so the shape, the position, starting position of the curve predicts the shape of type of soil. Hence we will, so starting point predicts type of soil, type of soil, that is fine grained or coarse grained or sand, silt, clay, gravel, etc., etc. Fine grained or coarser soil, or it is a sand, whether it is a sand, whether it is a silt, etc., etc., all those things. So starting location. Now look at the shape. What does it signifies? Shape signifies the distribution of particle in a soil. This curve is for a particular soil A and the curve goes like this, means the soil is having all sizes. Okay, this is the gradation. So what is curve A? You can say curve A represent a well graded soil, that is, what does it mean? That is, there is all size of particles of soil present in it. That is well distributed, okay, well distributed grains present in it. And this soil is only used basically in case of engineering in most of aspects. Now what is curve B? You can say, just look at curve B. Which one? Look, this curve B is starting from 75 micron and this is ending up just here. Means it is missing. There are maximum portion is missing. Maximum type of particle size is missing. So it is poorly graded. It can be considered as poorly graded. Poorly graded. Okay. Means there is no good distribution of all sizes of particle, but excess of similar types. Okay, similar types. This is poorly graded. Now curve C. I am telling this all only to make understand about, make difference in these terms, what is well graded, poorly graded, etc. Now curve C, look, it is straight at a particular location. Means the soil is of kind which have the same particles, same sized particles. So it can be considered as uniformly graded soil. Uniformly graded soil. Okay, that is a soil having same type, same sized particle. Now look at curve D. Curve D. It was something like that, na? It was something this fashion. What does it mean? That this, let me change the color. So particle size of category 1, particle size of category 2, and this entire portion is missing. Okay, so there are missing particle sizes. Okay, this particle size, this range is completely missed by this curve, and okay, that is can be considered as gap graded. Means there is a gap between two different particles size. Okay, there is a gap, so hence it is termed as gap graded soil, or and this is the shape of a gap graded curve. So have we understood the gradation and the category, and the how we can interpret the data from the particle size distribution curve? Let us proceed towards some important relations actually. And what is it? It is Saf factor. Let us look into Saf factor. Saf factor. What is Saf factor? Saf factor is a factor which it is a factor which represent the characteristic of the particle size distribution PSD curve. Okay, this is the factor which represent the characteristics of PSD curve, and Saf factor is basically related to coarse grained soils. Okay, related to coarse grained. We can also find for fine grained soil, but it is basically for coarse grained soil. Now, for coarse grained soil, there are some predefined particle size diameters which assumes higher significance than others. What are those? Those are D30, D60, D10. And among these three, D10 is considered to be effective diameter, effective size of solid. Okay, this is D10 is the effective size. Now what does it mean? What is D30, D60? Look, understanding one will clear all things. What does it mean by D30? Representing D30, it means that that size D of soil below which 30% of soil is finer. Okay, that dia below which 30% of soil is finer is represented as D30. Okay, and among D30, D60 and D10, D10 is the effective diameter of soil. So what are the Saf factors? There are two kind of Saf factor. There are two Saf factors actually. First is very famous one, and there is lot of confusion in these Saf factors, Cu. It is called as coefficient of uniformity. Okay, Cu, and it is calculated by the ratio of D60 over effective diameter size D10. The ratio of this is Cu, and what Cu represent? Cu, it represent the type of particle. It gives idea about type of particle, type of soil actually, and also it gives idea about gradation. Why? I will tell you now. Look, there are certain values, some values which goes like, if Cu is greater than 6, it is termed as well graded. Well graded, look, there is a point about gradation, note it down. Well graded sand. And what it represent? Type. It represent gradation. Okay, so both are included in Cu. Now other value is, if Cu greater than 4, then it is said to be well graded gravel. Now if Cu is approximately equals 1, it is called as uniformly graded soil. Now here there is no type, it is said to be uniformly graded soil, and in place of soil you will look at the particle size distribution curve, in which range the uniformly graded curve lies, and you will name it. If the uniformly graded curve lies in gravel section, you will say that uniformly graded gravel. Okay, or if the curve lies in sand section, you will say that uniformly graded sand. This is what the idea. So uniformly graded soil. So what we have, if Cu greater than 6, then it is termed as well graded sand, and if Cu greater than 4, it is termed as well graded gravel. Okay, so if Cu equals 1, it is termed as uniformly graded soil. I have said the idea about this, how to name this soil in this place. So look between these two values. So if Cu is equal to 5, then what you will tell? It will be uniformly graded gravel only, because Cu, unless and until Cu greater than 6, you cannot say that the soil is of uniformly graded sand type. So the next Saf factor which we have is Cc. It is termed as coefficient of curvature, and it is calculated as the ratio of D30 squared divided D10 multiplied D60. And what is it represent? It represents only about gradation of soil. The values are, if Cc is lies between 1 to 3, then only you will say that the soil is of well graded soil. Well graded soil. So for Cc less than 1, comma less than or greater than 3, what it will be? Poorly graded soil. So these are the two Saf factor which is to be remembered. So now we ended up with the index property of particle size distribution. In very next lecture we will start another index property, and which is important, and from that portion several numerical has been asked, and that index property is consistency of soil. So make sure you watch that lecture video. So in next lecture we will start with consistency. Well, thank you for being here and observing.